Hello viewers, in today's session we are going to discuss an important problem from derivatives, right? And here we are going to discuss the method of first principle to get the derivative of a function, right? So here we have to prove that the derivative of 1 over f of x is equal to a negative of f prime of x divided by f of x square, right? So here we'll see how we can find out the derivative of 1 over f of x from first principle. So let us start. So here we have the function say y is equal to f of x, and here we have to find out the derivative of the reciprocal of this function f of x, right? So we'll find out the derivative using the definition or the method of first principle. And the method of first principle says that the derivative of a function is given by dy over dx is limit h tends to 0. Here we have f of x plus h minus f of x over h, right? So this limit definition of the derivative is known as the first principle, right? So here what we will do, we'll suppose 1 over f of x is equal to some other function, say g of x, right? So let us denote g of x as the reciprocal of the function f of x. So it implies that we have to show that the derivative of g of x is given by a negative of f prime of x divided by the square of f of x. So now the derivative of the function g of x is given by a g prime of x, which is d by dx of g of x, right? So using this definition, definition of the derivative, we can now write the derivative of this function g of x as limit h tends to 0, and we have here f of x plus h. So now we have the function g of x, so we can now write g of x plus h minus g of x divided by h, right? So now simplifying it, we can now replace the g of x plus h by 1 over f of x plus h, because the g of x is equal to 1 over f of x. So when we change x from x plus h, we have 1 over f of x plus h, and g of x is equal to 1 over f of x, and here we have h. Now taking the LCM here, or simplifying this expression, we can now take the cross multiplication here. So we have f of x minus f of x plus h divided by f of x plus h. Then we have f of x, and then we have this quantity h, right? Now taking a negative sign common here, we can now write minus limit h tends to 0, and now we can take f of x plus h minus f of x divided by f of x plus h, f of x, and h. So now rearranging the terms here, we can now write g prime of x is equal to negative limit h tends to 0, f of x plus h minus f of x, and we can now take h in the denominator of this quantity, right? And then we have limit h tends to 0, and we have this remaining function, that is 1 over f of x plus h, and here we have f of x, right? Now let us see this quantity. Now, this is the limit definition of the derivative of f of x, right? Because see, the derivative of f of x is given by this limit. So we have this quantity equal to f prime of x, and now taking the limit here, we can now write 1 over f of x plus 0, taking h is equal to 0, and then we have f of x, right? So this is minus f prime of x multiplied 1 over f of x, because x plus 0 is x, and here we have f of x. So now we have minus f prime of x divided by the square of f of x, because when we multiply f of x and f of x, we'll get the square of f of x, right? So g prime of x is now equal to our desired result. So g of x represent 1 over f of x. So g prime of x is equal to d by dx of 1 over f of x, right? So the derivative of 1 over f of x is equal to a negative f prime of x divided by the square of f of x. So this is how, by making use of the method of first principle, we can prove this result.